Welcome to Copernicus AI, Frontiers of Science. I'm Matilda, and today we're diving deep into graph neural networks and their rapidly expanding applications. Adam, what makes the current research in this area so revolutionary? It seems like we're on the cusp of something big.
Thanks, Matilda. Absolutely. What's truly exciting is how GNNs are breaking down traditional data analysis barriers. For example, consider the work by Xinyu and Irwin in their 2022 paper, MECCH, Metapath Context, Convolution-based Heterogeneous Graph Neural Networks. The core idea is that GNNs are uniquely positioned to handle complex, interconnected data where relationships matter just as much as the individual data points themselves. This is a paradigm shift because it moves us away from treating data as isolated entries to understanding them within a rich network of dependencies.
So, instead of just looking at individual pieces of information, we're seeing how they all connect and influence each other. Can you give me a concrete example of where this is making a difference?
Certainly. Think about social networks. Traditionally, analyzing social media data focused on individual user profiles or isolated posts. But with GNNs, we can now model the entire network of relationships, who's connected to whom, how information spreads, and what factors influence opinions. Hongbo Bo and colleagues demonstrated this in their 2021 paper, Social Influence Prediction with Train and Test Time Augmentation for Graph Neural Networks. They showed how GNNs can predict social influence more accurately by considering the network structure itself.
That's fascinating. It sounds like a huge leap forward for understanding social dynamics. But what about applications beyond social media? Where else are GNNs making a significant impact?
The potential is enormous. Consider drug discovery, for example. We can represent molecules as graphs, where atoms are nodes and chemical bonds are edges. GNNs can then be used to predict the properties of these molecules, potentially accelerating the identification of new drug candidates. Or, think about knowledge graphs. Vast networks of information used in search engines and recommendation systems. GNNs are helping us reason over these graphs more effectively, leading to smarter and more personalized results.
So, it's not just about analyzing existing data, but also about predicting future outcomes and discovering new possibilities. I'm curious, are there specific architectural innovations in GNNs that are driving these advancements?
Yes, definitely. One interesting development is the exploration of hierarchical structures within GNNs. Jader Abreu and team, in their 2019 paper, Hierarchical Attentional Hybrid Neural Networks for Document Classification, investigated how to incorporate document structure into GNN architectures for better text analysis. The idea is that understanding the hierarchical relationships between words, sentences, and paragraphs can significantly improve document classification accuracy.
That makes perfect sense. It's like understanding the context and flow of a story, not just individual words. Now, are there any limitations or challenges that researchers are still grappling with in the field of GNNs?
Absolutely. One major challenge is scalability. As graphs become larger and more complex, training GNNs can become computationally expensive. Researchers are actively working on developing more efficient GNN architectures and training algorithms to address this issue. Another challenge is dealing with noisy or incomplete data. Real-world graphs often contain errors or missing information, which can negatively impact the performance of GNNs. So, robust GNN models that can handle these imperfections are crucial.
Those are important points. It's clear that while GNNs hold immense promise, there's still work to be done in terms of scalability and robustness. Another area of interest is how GNNs are evolving to handle dynamic data that changes over time. Are there any breakthroughs in that area?
While the provided research doesn't directly address dynamic graphs, it's certainly a hot topic. The ability to model and analyze evolving networks is crucial in many applications, such as predicting traffic patterns or tracking the spread of diseases. Researchers are exploring various approaches, including recurrent GNNs and temporal GNNs, to capture the temporal dependencies in graph data.
So, GNNs are not just static snapshots, but can also capture the evolution of relationships over time. Looking ahead, what are some of the most exciting future directions for GNN research?
One exciting area is the integration of GNNs with other machine learning techniques, such as reinforcement learning and generative models. This could lead to more powerful and versatile AI systems that can reason about complex systems and make intelligent decisions. Another promising direction is the development of explainable GNNs, models that can provide insights into why they make certain predictions. This is particularly important in critical applications, where transparency and trust are essential.
That's a crucial point. Explainability is key to building trust and ensuring responsible use of AI. What about the connection between graph neural networks and other types of neural networks?
That's a great question. Interestingly, there's emerging research suggesting a deeper connection than previously thought. For example, Chaitanya K. Joshi proposes in their 2025 paper, Transformers are graph neural networks, link in the description, that transformers, which are commonly used in natural language processing, can actually be viewed as a special type of GNN. This suggests that insights and techniques from both fields can be cross-pollinated, leading to further advancements.
That's a mind-blowing connection. It's like finding a hidden link between two seemingly disparate areas of AI. Adam, how can our listeners, whether they're researchers, investors, or simply curious minds, stay informed about the latest developments in GNNs?
Keeping up with the rapid pace of progress can be challenging. I'd recommend following leading researchers and institutions in the field, regularly checking out preprint servers like Archive, and attending relevant conferences and workshops. Also, there are many online resources and tutorials available that can help you get started with GNNs.
Excellent advice. Thank you, Adam, for breaking down this groundbreaking research and illuminating the transformative potential of graph neural networks. It's clear that GNNs are poised to revolutionize data analysis across a wide range of disciplines, from social sciences to medicine to artificial intelligence itself. This is a field to watch closely.
My pleasure, Matilda. It's an exciting time to be working in this area, and I'm confident that we'll see even more amazing breakthroughs in the years to come.